Hello dear student, this is Devangsha from LG Institute of Engineering and Technology under the LG University. So in our today's topic we are going to discuss about the sequential circuit. So far what we learn about the combinational circuit. If you understand, this combinational circuit are nothing but made up of the logic gates, right? So we have already discussed more combinational circuits is like magnitude comparator, multiplexer, decoder, subtractor, adder, all are combinational circuit. Why they are called the combinational circuit? Because this doesn't contain any memory element. That's why they can't store any information, right? Now at one point of stage, you have to design digital circuitry that would store a bit of information. Once any circuit is going to store the bit of information, you required a kind of memory. So here in combinational circuit there is no memory, right? So the value of present output is determined by latest input, right? So you can see this here. The example of all those kind of combinational circuits are adders, full adders, subtractors, multiplexers, decoders, etc. So you can see this diagram, there are n number of inputs. All inputs are digital inputs, and you have a combinational logic, and you just simply get the output, right? So here no output is feedback to the input, right? So it's simply there is no feedback system, there is no memory system, right? So this we define as a combinational circuit. Now based on that, again, if we again want to define a kind of concept of sequential circuit or the basics of sequential circuit, you can see there is a combinational circuit is there, but some part of output is again feedback to the input, right? So here the output also depends on the input terms, right? In what way you can just give the feedback of all the bits, that is through the memory elements, right? So here output bits are going to be stored in a memory, and that would also participate in a next cycle by using all those feedback bits as part of the input of the system or part of the input of the combinational circuit. So again, made up of the combinational circuits and the memory elements. These memory elements are device capable of storing one bit of information. So output depends on latest input as well as the previous state of output, right? So this is very important statement in terms of the sequential circuit if you want to understand, where the output depend. So here the output depends on the latest input and previous state of output, right? So example of sequential circuits are like flip-flops, counters, shift registers, that those kind of topics now we are going to discuss further. So we'll first start with the kind of flip-flop, where you can see, if you again want to understand, there are two types of sequential circuit. One is a synchronous circuit. So in synchronous sequential circuit, the state of the device changes only at the discrete time in a response of the clock pulse. Again, in asynchronous circuits, is like asynchronous circuits is not synchronized by a clock signal. The output of the circuit changes directly in response to changes in the input, right? So in synchronous, the complete process is like a simultaneous with respect to clock signal. In asynchronous, see, clock you are going to apply at a different time at a different stage, right? So based on that, see, in that particular combinational circuit, as a part of the memory, here we are going to take as a flip-flop, right? So here flip-flop is nothing but is going to store the one bit of information, right? So in a large scale flip-flop, you can use as a part of the memory. So you can see from this diagram, there is a combinational circuit, there is a some binary inputs, and that's some binary output of Z. But some part of the output that is again fed back to the input. So as a part of the input, it will consider as a present state, and again you can concentrate on the next state. So by that way, see, you can design a kind of sequential circuits by also applying the clock. So here in electronics, a flip-flop or latch is a circuit that two stable state can be used to store information, right? Flip-flop is a bistable multivibrator, and this is a like of more or less with the analog circuit concept. So the circuit can be made to change state by signals applied to one or more control inputs will have one or two outputs, right? It is the basic storage element in a sequential circuit. Again, you can check after the application of clock pulse, the flip-flop has a capacity to store 1 bit of information. So the overall you can design a kind of sequential circuit, right? Again, in a clock response in a flip-flop, either you can take a positive edge trigger, so you can see there is a clock is going up from 0 to 1. Same way you can apply a clock signal which is a negative edge trigger, where you can see the clock signal from 1 to 0, right? So you can see those arrows, and by that way you can apply the clock signal either 0 to 1 or 1 to 0, but that depends on the edge trigger. So you can see at any one of the edge, maybe a positive and negative, you can see the arrow, and by that way you can apply the clock signal, right? So in a way, what is a clock signal? See, clock signal is nothing but kind of energy signal where you apply to the sequential circuit, so all the blocks wake up at the same time, right? So that's why we require a kind of clock signal, right? So again, based on that, if we first try to design a kind of flip-flop, and that flip-flop or latches are nothing but the circuit that can store and remember the information, and what way they are going to store information, that we are going to learn a different kind of flip-flop. So here they are the kind of circuits that are used in computers to store the program information like RAM memory or register. So ultimately here we are using flip-flops to design to make the memory, right? So flip-flops can be used to store 1 bit or binary bit or data. The data may represent the state of sequencer, the value of counter, ASCII character in a computer's memory, or other piece of information. So from that, if we learn about the kind of flip-flop and latch, and if you want to design flip-flop and latch, let us first start with the difference between flip-flop and latch, right? So flip-flop and latch both are nothing but the basic block of sequential circuit, but there is a suitable difference between this of two. The flip-flop continuously checks its inputs and corresponding changes its output only at times determined by the clocking the signal. So right, clock is very important in terms of the flip-flop, right? But in a whereas in a latch is a device which continuously checks all its input and corresponding changes in the output independent of time determined by the clocking signal. So see, this is a very minor difference where in one case there is a continuously is going to check the output signal, uh, not dependent on the time of the clocking signal, but another one is depends on the clocking signal, right? So this is how you can differ both this two. So SR latch you can also consider as a sequential logic gate. So in this particular SR latch we can make a cross connection with the NOR gates as well as a NAND gate. Let's say first discuss with the NOR gate. You can see this is the kind of SR latch where as such you have connected the NOR. So you can see the truth table of NOR here. You take the two inputs A and B, and you find your output Y is equal to A plus B of whole bar, right? So what is important part here? If both the inputs are 0 0, then and then you will get the output is 1, right? And rest of the positions you will see the output is 0, right? So here if you see the truth table or functional table of this SR latch, you can check, you can apply 0 to 1 to reset and set pin. That's why it is called the RS latch, where as such this is a NOR gate. So first you consider, let's say Q is equal to 1 at the initial condition. If Q is equal to 1, see one of the input is at the second NOR gate is 1, and set, you can check the set, let's say it's a 0, right? So if set is 0 and the previous is 1, see 0 and 1, your output becomes 1, so your Q bar becomes 1. That means must be Q is equal to 1. So here you can see from this latch there are two NOR gates are cross coupled with each other, and one of the output is, let's say, Q, the another one is a Q bar. There is always a kind of sequence, or this is a kind of pattern where one of the output is the complement of another output, right? So from that, if you apply R is equal to 1 and you take S is equal to 0, if you take R is equal to 1, and let's say your previous Q bar is 0, or let's say your previous Q bar is 1, so you have a reset R, that is a 1, the previous Q bar is 1. So from that you can see the R is equal to 1, Q bar is equal to 1, your Q becomes 0, because 1 1 you get the 0. Now this kind of conditions is normally we can define where your R is equal to 1 and the Q is equal to 0. That means this condition we define as a reset condition. Same way, if you take S is equal to 1, in that case if Q goes to 1, this condition is called a set condition, right? So from NOR gate to table you can be able to understand the sequential circuit of this SR latch, right? So again, in your consideration, always start the assumption with either q is equal to 1 or 0, and you can just try to understand the truth table. Now you can see this particular where q is again fed back to the second stage of NOR gate, and Q bar is again feedback to the first stage of NOR gate. That's how you can make a feedback from this two connection. Now based on that, you can see the kind of sequential circuit you are used again with the help of the NAND gate, where you can see there is a truth table of NAND gate where you apply 0 0, you'll have output is 1. So when NAND goes to 0, when both the inputs are 1 1, it goes to 0, right? So based on that, again you take Q is equal to 1, and by that way, see, you can take q is equal to 1, you can take r is equal to 1, and your output goes to q is again goes to 0 later on. See, this terminology we again define as a kind of reset condition, right? So if r is equal to 1, s is equal to 0, q goes to 0. This is a reset condition. If s is equal to 1, r is equal to 0, and q goes to 1, this is called a set condition, right? So always from this kind of latch, you can have a set and reset conditions, right? Now further we define, as such we have just taken the primary structure of this latch. Now you further expand this and you introduce one more important signal, which is called the clock signal, right? When clock comes, the complete terminology is triggered, right? So this is what you can see here. The kind of operation of the basic SR latch can be modified by providing an additional control input determines when the state of latch can be changed. So here additional control signal here we are going to apply as a clock signal. So you can see the clock signal where I'm again going to connect two more gates. Just you can see when the clock comes, see when the clock is 0, the complete state is, you can consider as a no change in output. But when clock goes to 1, so if you put the clock 1, see you can check the corresponding R and S. If R is equal to 1, check from, if clock is 1, R is 1, see you will find a specific change in this one. So if clock is equal to 1, R is goes to 1, see your output goes to 0. That output you again coming to here, and you can check your Q bar is goes to 0. Now this condition here, when R is equal to 1, S is equal to 0, when clock comes, when Q goes to 0, this condition we define as a reset condition, and vice versa for the set condition. And for 0 0, you are not going to have any change. Now this is very very important. If both the inputs of set and reset goes to 0, you have no change. That means the previously data, whatever previously you have q or q bar, that can be, there is no change, so that can be stored inside this particular flip-flop. That's why the flip-flop we are using, or latch we are using, to store one bit of information, right? See, what is the limitation here? When both s and r are 1 1, see, you are never going to have q and q bar is a complement of each other, right? There has to be 1 1 or 0 0 answer. That means this condition has a limitation. This condition is an indeterminate state, right? So this is what one of the biggest limitation of SR latch. Yes students, thank you very much. So what we learn as a part of the summary, we learn about how we can construct the latch.